Hi students, today's video is about Chemistry 9, Solved Review Exercise of Chapter Number 2. Let's start review exercise. Encircle or tick mark the correct option. Anything that has mass and occupies space is called? The correct option is matter. 2. Following are states of matter? The correct option is all of these because solid, liquid and gas are states of matter. Macroscopic properties are those properties that can be visualized by? The correct option is the naked eye. Matter can be described by both its? The correct option is physical and chemical properties. 5. A substance formed when two or more elements combine chemically? The correct option is compound. Let's start short question answers of exercise. Question 1. Can you write the formula of carbon dioxide gas that we exhale? Answer. Yes, the formula of carbon dioxide gas that we exhale is CO2. Question 2. Define element, compound and mixture? Answer. Element. An element is a pure substance made up of only one type of atom. Example: oxygen, O2, and gold, O. Compound. A compound is a pure substance made up of two or more elements chemically combined in a fixed ratio. Example: water, H2O, carbon dioxide, CO2, mixture. A combination of two or more substances, elements or compounds, that are physically mixed together but not chemically combined is called mixture. Example: air, saltwater. Question 3. Differentiate between compound and mixture? Answer. Compound is a pure substance while mixtures are impure substances. Compounds are made up of two or more elements chemically combined in a fixed ratio. Mixtures are combination of two or more substances that are physically mixed together but not chemically combined. Compounds can have properties different from its constituents. The properties of a mixture are same as the properties of its constituents. The constituents of a compound can be separated only by chemical methods. The constituents of a mixture can be easily separated by physical methods. Examples of compounds are water and salt. Examples of mixtures are air and salt water. Question 4. Differentiate between concentrated and dilute solution? Answer. Concentrated solution are those which contain relatively large amount of dissolved solute in the solution. Dilute solution are those which contain relatively small amount of dissolved solute in the solution. 98% sulfuric acid is an example of concentrated solution and 5% sulfuric acid is an example of dilute solution. Let's start long questions of exercise. Question 3. Define the term allotropes. Explain the allotropes of carbon? Answer. Allotropes. The property of an element to exist in different physical forms is called allotropy. These different forms in the same physical state is called allotropes. Allotropes of carbon. The important allotropes of carbon are diamond, graphite and buckyball. Graphite. Graphite is composed of flat two-dimensional layers of hexagonally arranged carbon atoms. In a layer, each carbon atom is covalently bonded to three other carbon atoms. Weak intermolecular bonds exists between each layer which allows the layer to slide over one another without breaking the bonds. It is soft and slippery, used as a lubricant. Graphite is a good conductor of electricity. Diamond. It is the hardest and purest crystalline allotrope of carbon. In its structure, each carbon atom is covalently bonded with four other carbon atoms, forming a rigid network of tetrahedral shape. This tetrahedral, three-dimensional arrangement makes it the hardest substance with a very high melting point. Diamond is a non-conductor of electricity. Buckyballs, carbon-60. They are also known as fullerenes, having a football-like fused hollow ring structure made up of 20 hexagons and 12 pentagons. Each of its 60 carbon atoms are bonded to 3 carbon atoms. Question 4. What is the difference between homogeneous and heterogeneous solution? A homogeneous mixture is that mixture in which components mix with each other and its composition is uniform throughout the solution. A heterogeneous mixture is that mixture in which the composition is not uniform throughout and different components are observed. In homogeneous solution, components cannot be seen through naked eye. In heterogeneous solution, components can be seen through naked eye. In homogeneous solution, components cannot be separated easily. In heterogeneous solution, components can be separated easily. Examples of homogeneous solutions are air, salt solution, etc. Examples of heterogeneous solutions are mixture of salt and sand solution. Question 5. Differentiate between solution, colloid and suspension? Answer. A solution is a homogeneous mixture of two or more components. A colloid is a heterogeneous mixture of two or more components. A suspension is a heterogeneous mixture of two or more components. The particle size of solution vary from 0.1 to 1 nanometer and not visible by naked eye. The particle size of colloids vary from 1 to 10 exponent 3 nanometers and not visible by naked eye. The particle size of suspension is greater than 10 exponent 3 nanometers and visible by naked eye. Solution particles can pass through normal as well as ultrafilter paper. Colloid particles can pass through normal filter paper but not through ultrafilter paper. Suspension particles cannot pass through normal as well as ultrafilter paper. Solution particles cannot scatter light due to smaller size. Colloid particles can scatter light due to Tyndall effect. Suspension particles can scatter light due to Tyndall effect. In solution, particles does not separate. In colloid, particles does not separate. In suspension, particles separate or settles down when stationary. Example of solution is seawater. Example of colloids is milk and example of suspension is muddy water. Question 6. If there are 18 protons in the argon atom, then what is the atomic number of argon? Answer. As there are 18 protons in the argon atom, so, the atomic number of argon will also be equal to 18 because atomic number is always equal to the number of protons. Question 7. Describe states of matter with example. Answer. States of matter. Solid. A solid has a definite shape and volume. Particles are tightly packed in a fixed arrangement. For example, ice, diamond, etc. Liquid. A liquid has a definite volume but takes the shape of its container. Particles are close together but can move past one another. For example, water, oil, milk, etc. Gas. A gas has neither a definite shape nor volume. Particles are far apart and move freely. For example, oxygen gas, etc. Plasma. A highly ionized gas where electrons are separated from atoms, often found in high-energy environments. Plasma are electrically conductive. For example, the sun, lightning, welding, etc. Question 8. Differentiate between the following. Part A. Colloid and suspension. Answer. A colloid is a heterogeneous mixture of two or more components. A suspension is a heterogeneous mixture of two or more components. The particle size of colloids vary from 1 to 10 exponent 3 nanometers and not visible by naked eye. The particle size of suspension is greater than 10 exponent 3 nanometers and visible by naked eye. Colloid particles can pass through normal filter paper but not through ultrafilter paper. Suspension particles cannot pass through normal as well as ultrafilter paper. Colloid particles can scatter light due to Tyndall effect. Suspension particles can scatter light due to Tyndall effect. In colloid, particles does not separate. In suspension, particles separate or settles down when stationary. Example of colloids is milk and example of suspension is muddy water. Part B. Elements and compounds. Answer. An element is a pure substance made up of only one type of atom. A compound is a pure substance made up of two or more elements chemically combined in a fixed ratio. Elements cannot be broken down into simpler substances. Compounds can only be separated into elements through chemical reactions. Example of element is oxygen O2 and example of compound is water H2O. Part C. Concentrated and dilute solution. Answer. Concentrated solution are those which contain relatively large amount of dissolved solute in the solution. Dilute solution are those which contain relatively small amount of dissolved solute in the solution. 98% sulfuric acid is an example of concentrated solution. 5% sulfuric acid is an example of dilute solution. Question 9. Examine the concept of solubility. Answer. Solubility. Solubility is the maximum amount of solute which is dissolved in a specific amount of solvent at specific temperature. The solubility of a substance depends on solvent used, as well as temperature and pressure. Effect of temperature on solubility. Increase in solubility with temperature. For example, KCl, ammonium chloride. Decrease in solubility with temperature. For example, sodium sulfate and calcium hydroxide. Table 2.2 shows the solubility of some salts in gram per 100 gram of solvent at different temperatures. The graph shows the solubility curves. At x-axis temperature in degrees Celsius is taken and at y-axis gram of solute per 100 gram of water is taken. Here water is used as a solvent because water is a universal solvent. Think tank. Question 10. Why is a solution considered a mixture? Answer. A solution is considered a mixture because it consists of two or more substances that are physically combined but not chemically bonded together. In a solution, the substances involved retain their individual identities and properties. All solutions are mixtures because it is two or more substances mixed together. Question 11. How will you test whether given solution is colloid or solution? Answer. Light scattering experiment can be used to determine whether a given solution is colloid or solution. A strong beam of light is allowed to fall on the solution. If the light scatter in different directions, then it means the given solution contains large particles of solute and it is a colloid. Thanks for watching and subscribe for more videos, and don't forget to press the bell icon.